The title of today's paper is Continuous High-Frequency Pesticide Monitoring to Observe the Unexpected and the Overlooked, published in the Water Research X, in 2021. Synthetic plant protection products, PPPs, are a key element for a large part of today's global food systems. However, the transport of PPPs and their transformation products, TPs, to water bodies has serious negative effects on aquatic ecosystems. Small streams in agricultural catchments may experience pronounced concentration peaks given the proximity to fields and poor dilution capacity. Traditional sampling approaches often prevent a comprehensive understanding of PPPs and TPs concentration patterns, being limited by trade-offs between temporal resolution and duration of the observation period. These limitations result in a knowledge gap for accurate ecotoxicological risk assessment and the achievement of optimal monitoring strategies for risk mitigation. We present here high-frequency PPPs and TPs concentration time series measured with the autonomous MS2 field platform that combines continuous sampling and on-site measurements with a high-resolution mass spectrometer, which allows for overcoming temporal trade-offs. In a small agricultural catchment, we continuously measured 60 compounds at 20 minutes resolution for 41 days during the growing season. This observation period included 8 large and 15 small rain events and provided 2,560 concentration values per compound. To identify similarities and differences among the compound-specific concentration time series, we analyzed the entire dataset with positive matrix factorization. 6 factors sufficiently captured the overall complexity in concentration dynamics. While 1 factor reflected dilution during rainfall, 5 factors identified PPPs groups that seemed to share a common history of recent applications. The investigation per event of the concentration time series revealed a surprising complexity of dynamic patterns. Physicochemical properties of the compounds did not influence the dissimilarity of chemographs. Some PPPs concentration peaks led while others lagged by several hours the water level peaks during large events. During small events, water level peaks always preceded concentration peaks, which were generally only observed when the water levels had almost receded to pre-event levels. Thus, monitoring schemes relying on rainfall or water level as proxies for triggering sampling may lead to systematic biases. The high temporal resolution revealed that the Swiss national monitoring integrating over 3.5 days underestimated critical concentration peaks by a factor of 8 to more than 32, captured 3 out of 11 exceedances of legal acute quality standards, the relevant values in the Swiss water protection law, and recorded 1 out of 9 exceedances of regulatory acceptable concentrations, the relevant values for the PPP's registration process. MS2 field allowed for observing unexpected and overlooked pesticide dynamics with consequences for further research but also for monitoring. The large variability in timing of concentration peaks relative to water level calls for more in-depth analyses regarding the respective transport mechanisms. To perform these analyses, spatially distributed sampling and time series of geo-referenced PPPs application data are needed.